system of 3 equations in 3 variables. We're going to solve it by elimination. So here's our system, our example. We follow our general strategy. We're going to adjust equation number 2 and 3 in order to add them. So we're going to go work on these two right here. We're going to add them to get an equation where z is eliminated, and we're going to call that new resulting equation number 4. Then we're going to adjust equation number 1 and 3. So we're going to work on these two in order to add those together to get an equation where z is eliminated, and call the new resulting equation number 5. Then we're going to take this 4 and 5 and solve it as a 2 by 2 system using elimination or substitution or whatever happens to come up. And now you'll have x and y solved. You'll plug those in to the easiest original equation to get z, and you'll be done. So our first goal is to work on 2 and 3 to eliminate z. So I see that I'm going to take equation 2, and I'm going to have negative 2 times 3, equation 3, to put a negative 2 right there, so when I add it with a 2z it'll cancel out. So that's my goal. So I have to accomplish negative 2 times equation 3. Negative 2 times equation 3, distribute in, and get this. Okay, then over here I'm simplifying. I'm taking, well actually I didn't simplify that, I kept it the way it was, but I could have. Okay, so I'm doing 2 plus negative 2 times 3, the original goal. So I take 2, equation 2 is right here. This altered number 3 is right here. I'm going to add those straight down and get negative 6. The z's cancel out like I wanted. Negative 3y, negative 3x. So that's the number 4 equation. Now I'm going to work on 1 and 3. So I mapped out the strategy 1 and 3. So if I have a negative 1 in front of this z, then when I add it to this z in number 1, it'll cancel out. So that's why this strategy is here. So we're going to do negative 1 times 3. Here is 3's equation. Negative 1 distributes throughout and gives this. Now we're going to accomplish equation 1 added to that negative 1 times 3. There's equation 1. There's the altered equation 3. Add them down. Negative x. The y and z both cancel out. That's not usual, but it's okay. We'll take it. It wouldn't matter. We're still going to cancel out the z, and that's the way we set it up. But we cancel out the y and got that for free. Okay, so on this side it's negative 3. Alright. So we write down the system of 4 and 5, the 2 by 2 system. Alright, we're going to simplify the system because we got a 3, a 3, and a 6. We also have this negative x equals negative 3. We can simplify all that. So on number 4, we're going to divide through by negative 3. And then get x plus y plus 2. Because negative 6 divided by 3 is 2. Negative 3 into negative 3y is y. So this is a simplified number 4. And negative x equals negative 3. Multiplying by negative 1, x equals positive 3. So that's the simplified number 5. So I would normally do this, I would have a y here normally. And I would just do it, solve it by elimination. But since I have x sitting here solved for already on this one, I'm going to use it. I'm going to substitute it in to equation number 4. Here's equation number 4. Sub in numbers x equals 3. 3 plus y is 2. Subtract 3 from both sides. Y equals negative 1. Okay, so far we have x equals 3 and y equals negative 1. Now we substitute it into the simplest equation of the original, which happens to be number 1. That's pretty simple right there. So we substitute x equals 3, there's a 3, y equals negative 1, that's y equals negative 1, plus z equals negative 1, 3 minus 2 is 2, 3 minus 1 is 2, 2 plus z equals negative 1, we're here, and now subtract 2 from both sides and z equals negative 3. So our solution is x equals 3, y equals negative 1, and z equals negative 3. Or you could say the solution to the system is the point 3, negative 1, negative 3. Let's do a calculator check. So here's our original system. Here's the A matrix coefficient matrix of the coefficients. You see there, like, let's just check this one. It should be 1, negative 1, and 2. So that checks out. The B matrix is the answer column matrix. Negative 1, negative 2, 2. With those on the home screen, the inverse matrix of A times the B gives us the answer point 3, negative 1, negative 3. And that checks out to x, y, z. That checks out to this. 3, negative 1, negative 3. 3, negative 1, negative 3.